going to see how temperature will affect the position of the equilibrium. Temperature change will only affect a reversible reaction that is in equilibrium if that reaction is either an endothermic process or an exothermic process. A decrease in temperature will favor the reaction that liberate or generate more heat. So this is to say that temperature decrease favors an exothermic process. How do you know that it is an exothermic process? The enthalpy change of that particular process will be given. If the enthalpy change has got a negative value, then it is an exothermic process, and a decrease in temperature on this exothermic process will favor that particular process. So in short, exothermic processes will require cooling for more yield to be achieved. Okay. Now, what about increase? Increase in temperature. Temperature increase favors an endothermic process. An endothermic process is a process that absorbs heat energy from the environment. So it needs heat energy. So if you supply heat energy to it, it will appreciate. And the reaction rate will increase. Appreciate in quotes. This is delta, this is H, then this is plus. So an endothermic process has got a positive enthalpy change. This is what I'm saying. It absorbs heat energy from the surrounding. It is favored by heating. So if you raise the temperature, you favor that particular process. If an equilibrium mixture is neither exothermic nor endothermic, then change in temperature, that is either cooling or heating, has no effect on the position of the equilibrium. Examples of equilibrium mixtures influenced by temperature change. Consider this particular equilibrium mixture. Whatever we have on the reactant side here is a nitrogen 4 oxide. Then on the reactant side, whatever we have there is dinitrogen tetraoxide. It is a liquid after cooling, lowering the temperature. Nitrogen 4 oxide is brown in color. Dinitrogen tetraoxide is yellow liquid. To convert nitrogen 4 oxide to dinitrogen tetraoxide, we need to cool. That process requires low temperatures for it to happen, but it is a reversible process. To change from dinitrogen tetraoxide, that process now will require heating, where we raise the temperature. We can now ask ourselves, in that particular system in equilibrium that involves dinitrogen tetraoxide and nitrogen 4 oxide, forward reaction requires low temperatures. It is an exothermic process. Then the reverse reaction, that is now converting from dinitrogen tetraoxide to nitrogen 4 oxide, is an endothermic process. It requires heat energy from the surrounding. If the forward reaction is exothermic, then definitely the backward reaction will be endothermic. So when temperature is decreased, that is now cooling, this is what will happen according to what I have said. The forward reaction will be favored, so we will have more dinitrogen tetraoxide forming. The position of the equilibrium will shift to the right. All right, so an exothermic process because of the cooling that is required here. The brown color of nitrogen 4 oxide will fade, and then the yellow color of the dinitrogen tetraoxide will intensify. Okay, increase in temperature. This is what we will note. Equilibrium will shift to the left, then the rate of the backward reaction will increase, then the brown color will intensify because the backward reaction leads to formation of nitrogen 4 oxide. then the yellow color, that is of dinitrogen tetraoxide, will faint, because more of dinitrogen tetraoxide will now be converting to nitrogen 4 oxide. Catalyst. Catalyst has no effect on the position of equilibrium. So in short, a catalyst does not affect the position of equilibrium, but the catalyst will help this particular reaction to attain equilibrium very fast.